Alright. Okay, we're going to do this real quick here. It's going to be a fast video. 1, 2, 3, 4, 5, 6. I do that countdown for some audio syncing later on when I have to combine video and audio. Alright, this is SMT at DDR. Once again, this is going to be about the improvement of the proxy server's hide-and-seek for finding and avoiding players online you don't want to deal with. This is the improved version, and this one's going to be all about code. It's going to move pretty quick, and I'm going to assume that you have at least some background in Python and C. So, we're going to talk about mixing Python and C together, moving binary data between the world of C and Python, why they'd have to do this for hide-and-seek, the new logic of hide-and-seek, taking apart, examining, and rebuilding the player list, the unseen dangers of direct memory access to Python, and the job of freeing malloc and when you're mixing between these two languages. So that is the end of the slideshow. You see that? So we're just going to go right to it. Okay. So I'm going to start program screen because I like my split screens. First test, PY, greeting. Okay. This has a function. English greeting. My name. Okay. Return hello %s. How are you? Alright. Def main. Print English greeting. Pikachu. Okay, and if name equal main. Okay, split screen. Python PY. So, oh, hold on. My name. Almost forgot that. Alright, so it printed out. It printed out. Okay? Okay. So we want to print out a Japanese greeting, but here's the thing about the Japanese greeting. We want to do this in C. Let's talk about that. Include sdio.h. Okay, char star. Japanese greeting. Char star my name. Okay, template. Char star template equal. Konnichiwa. Genki desu ka? Okay, that's the Japanese greeting here. And char star j greeting equal malloc. So Sterling template. Right, so the memory alloc needs to be long enough for this, for the template, plus long enough for the name we're going to add. Now consider that my name is going to take the place of that %s, so we don't actually need the, that's going to be, so that's the -2, because we're removing it at the %s is going to disappear in place for the name. And the program, or the function I'm going to use called sprintf into this buffer is probably going to append a null, so let's do -1, so we have enough room for that null. So there you have it. Let's see here first. We got to test this thing. Yeah, because it could happen. What if it failed? No, sure, you got to test those mallocs. So sprintf j greeting template my name. Okay. Return j greeting. Okay, and that's how that would work. Now let's int main int arg c char star arg v. This is kind of the old school way of doing it, actually. I think a lot of people nowadays have been doing this the hip way, I suppose. Hip, C can be hip. Here we are. Char star. My name equal Pikachu. Chu again. Let's see, char star J greeting equal. Actually, I don't need to do this right now. Maybe later. Okay, Japanese greeting. Pikachu. Okay. If J greeting, because you know my return null. Print F %s carriage turn line feed. And Linux might just be a carriage turn or just a line feed, one of those. Let's see here. J greeting. Okay, and it worked. So you know. Yeah, let's leave it like that. Okay. Else printf problem got null from J Japanese greeting. Right, oh my gosh, the problem. Alright, so how it goes, return 1. Right, return non-zero if there's a problem, otherwise return 0. Okay. Alright, gcc dash wall dash o gg. Okay. Error. Let's see here. Semicolons. Don't forget those. Okay, implicit. You don't want implicit functions. Implicit kind of means that if, say, for example, you're working with a big group of people writing code, and somebody for some reason re-implemented their own malloc or their own Sterling, you would you'd pick up their copy. And that would be a problem because the compiler have to figure out which one matches, and they'll pick that one up instead of picking up the default if somebody had one in there or something like that. I would argue, though, that anybody who redefines their own function have the same name as the custom, or the ones that come with the GCC compiler. That might not be good best practices to do things like that. So I don't think people should be doing that. String.h. Alright. Okay. See that? It works. Now here's the thing. We want to call this from Python. So we're gonna set that up right now. Enter swig. What's swig? Let's see here. Alright. Swig wiki. So swig is there's a whole long story to it. The thing is, though, that you can write low-level code, sort of low-level. Assembly is really low, but you can write a C++ code and call it from these higher scripting languages that are a lot faster to code in, like Ruby or C#, Java, Python. So I want to do it for Python. I could put all kinds of stuff here, like Java, Ruby, but I'm a Python guy, Python+C guy. So here's the thing. We're gonna do like this: Japanese greeting, and it takes an interface file. The interface file doesn't exist because I haven't made it yet. Let's see here. Example 1 to Japanese greeting. Okay, so we're gonna edit this, and you know, this is not too bad. I want the module to be called Japanese greeting. Okay, Japanese greeting. And the function that in this C program I want to be exposed is that char star Japanese greeting. Char star my name. Okay, you know, and so I put it down here. This is the one that needs to reach. The one that's up there inside these thing right here. If you leave those out, you're going to get an implicit error again. So you just need to do it this way. Okay. So now swig Python Japanese read I. Look what he gave me. Okay, I got a py file and a rat file.c. We're going to compile. Now, what does that mean? A GCC-C thing there. Man, GC. You see that? The C option says not to run the linker, then it just creates the object files with the .o files. And you know, if you work in a big C shop, a lot of developers, they may compile their own oops. And you see all these errors, a lot of errors. You think like, oh, what happened? And you know, you have to include, for this SWIG for Python, you have to include the Python.h that comes on your system if you install the Python development packages. And I'm talking about this thing here. See that? Python.h right here. So, but you don't actually type Python.h at this command line. This include in C, it means the directory where to look for it. So the directory that's in is Python 6 like this. And there you go. See how that worked? And we'll make sure there's some no warnings. Okay. So yeah, and in the developer world, they may work in big groups, and everybody can have their own unit test. See, I have my own unit test, kind of, right? That's the main that calls it, so I can have my own test, make sure my function works before I send it off into the build or something overnight, and everybody can include my .o file into the big project, you know, that kind of thing. So anyways, in the world of Linux, like Windows DLLs are like shared dynamic libraries, something like that, and shared objects here in the world of Linux. So we're going to combine -o Japanese -o and Japanese greeting.so. Okay. Now I have a .so. All right. vi py. Now that ._so is what SWIG uses to import and grab the C program. That's how that works. I'll show you that. I'll show you the contents of that here in a second. It's the contents of the PY file that SWIG generated. Okay, see that? Now, let's say print Japanese. Python, right? Okay. PY. See that? And so I called the C program from Python. That's what happened there. Got the string, no problem. And notice this. So let's see what's in here. This is actually not made to be readable. You see, it says not to make change if you really know what you're doing. This really isn't meant to be looked at, unless you're some kind of a super geek hacker or something like that, and you really can get in here and you think you know what changes you want to make here that somehow the SWIG thing didn't know better and you think you know better. I guess you can come in here, but you know, it's not really designed for that, so you really don't need to come in here. But yeah, so that, you know, that's how that goes. But I don't need to look at that. So that works, right? No problem. No problem. So let's make this more interesting. So I'll do this. Okay, I'm gonna replace all the Pikachus with a Professor Oak. Okay. That looks doesn't look so scary, right? That should print too. Right? Python greeting. Yeah, look at that. Professor Oak, no problem. Okay. We're gonna do something else though now. Okay. Equal. Let's see. Professor Oak. My name. Get rid of quotes. Quotes. We're going to put in a variable. Folks, I'm going to change it to one place real quick. Jump to the bottom, clear screen, run it again. See, it still works. Alright, cool. Now we're going to do something really nasty. What happened to that O? See the bottom one, the Japanese one? The oak disappeared from Professor Oak. Why is that? For those who know C, the concept of a string in C is a long set of bytes until it runs into null, right? So you give it a pointer, and from there it marches forward and through memory until it hits a null, and from where it started to where it hit the null is the string. So the problem is this, for all these functions, these string functions, things like this, when I use sprintf to write into it, when I did stir lang, this gave the wrong answer because it'll stop at that null and says, okay, it only sees the word professor and thinks it's done. That space right here in oak is not interpreted by this process or this process, and that's what happened. That's why it disappeared. So we need to change all this stuff. This is kind of the thing I have with the binary data in Tatsunoko versus Capcom. The binary data has nulls in the middle of it, so I can't do things like this to get it back. I need to figure out a way to get around this limit. Here's how we're going to do it. Okay, we need to fix this function so it can handle that case. Okay, first of all, we're going to add this. You're probably wondering, what is uchar pointer? Okay, I'm going to show you right now. Uchar.vi uchar. It's simply a struct. See, uchar pointer. It's a structure, has a size, and a pointer to some memory somewhere, some data. Okay, that's all it is. That's all it is. So instead of calling this template, we're going to call this template. Let's just call it 1. Okay, so first template is that. Okay, star template 2 is space, or actually, let's see, space. Then we put the name. It's gonna be a period, space, des ska. All right. Okay. So we had these two. Now this thing here, here's what I'm gonna do. Uchar pointer. This is gonna be a pointer there. Malloc. Size of uchar pointer. So we're gonna malloc some memory, and if jgreeting, return null. All right. Okay. And then we're going to do what else? We're going to say malloc. If this worked, and I have a structure, right? jgreeting data, okay, equal malloc, and this is going to equal let's see here, let me type let's see, okay, let's do this, jgreeting size, okay, equal, right, because the struct has a size, so we're going to integer equals strlen template 1, okay, plus strlen template 2, right, okay, plus, now I can't say strlen, right, we already talked about it. String functions can't handle the nulls in the middle, so all that string stuff, you can't do it. So here's how it has to go. Okay. Okay, let's see here. Plus size, and I believe a plus 1, so I can put a null at the end. So okay. Yeah, I think that's it. Let's see here, and then I'm going to do jgreeting data equal malloc jgreeting size. Okay. Let's see. If not jgreeting data. Okay. Free jgreeting, because I malloc that above, right? So I need to free that, and now return null. That's some kind of problem, but it probably won't be. So let's see. Stir cat. I'm gonna say stir cat into greeting data template 1. That's the first thing I'm going to do, because that has no nulls in there, right? It's just konnichiwa space. Now this area, this data is not initialized or properly, so, and neither was the one above. So we need to fix that. It's not really good to use memory this way, because you don't know what's in it, and you might have a problem, especially since I'm depending on stircat to work. I'm depending on nulls to be in the right place. It's probably there, but you don't know that, so you need to test it. You need to make sure it's there. So I'm going to tell you this greeting here, 0 size of. Okay, and size of is what I mallocked. Char pointer. Okay. So I need to make sure that I fill that place with nulls properly, so it's set up. And that actually goes for this. It goes for this place too. So after I know that I've mallocked it, okay. Here, where data is, I want to put nulls, which is 0 byte. I need to size of. Okay. Actually, no size of. I know what the size is. Data was mallocked J greeting size. Okay, that integer. So that's how that's going to go. So we make sure it's the data's oh wait, I forgot something here. Data. Okay. So let's see here, right? Char star pointer degree and size of, and clean it up, make sure it's done right. This one, okay. This looks good. So stircat. Now I can't do this. Right? As much as I would love to do this, stir greeting data. My name. I can't do that. There's a null in there, and what's going to happen is that Professor Oak thing is not going to make it. You're just going to get Professor again, because it's going to stop at the null. So how do you get around that? I could do a for loop and just kind of write into it like an array or something like that. But you know what? You know what I'm going to use? Memcopy. Memcopy is perfect for this. Okay? It takes a pointer, the destination, the source, and how many bytes from that source to write. That's how that works, okay? Good times. So I'm going to say memcopy to J greeting data. Where is that name? Okay. My name, right? The source, and the size. And where's this size thing coming from? I have to add that here, because there's no way for me to know the size. So I have to do that. Okay. And in the world of Python, Python has no problem calculating the length of a string with a null in it. So I can just do this, my name, Python, when I call this function, and it will give me the right number. So that way, when I get here, I know int size is the right thing, so I can use it throughout the function. Okay, so let's see, right? Size one. Okay, so we're all set. Now you know what? There's a problem here, and the problem here is this is just going to overwrite data, right? It's pointing at the beginning, so we need to move this pointer of memory. It is now stir. I can do this, stir len template 1. That's this length of this string from this memory offset, since I copied it just now. Then it's over here. The pointer, you have to move forward in memory and get over here about, and do that. So now we're going to copy an end size. That's what this is. And then we're going to do this, mem copy J greeting. Do it again. Data plus stir len template 1 plus size, because we wrote more. And now we're going to write template 2. Okay, template 2, right? And this how much? Because template 2 is a regular string with no nulls in it, I can count on this template 2 to give me the right answer. See that? Okay, and copy memcopy. So see, one stircat and memcopy, because I can't. The nulls in the middle of the string will just cause me problems. So I have to do it this way. Once the null gets involved, memcopies. And guess what? One more thing I need to do. J greeting. Okay, data. Let's see. So from here, let's see. So from this location, we want to append a null here. So from this location, right, plus size plus Sterling. So we're saying from here, that's what this is, from here, move forward, J greeting data, move forward, Sterling, plus size, let's see here, right, okay, here we're going to say equal 0. This is where we're basically adding the the null at the end of this, like that. It's all the same. Okay. I said binary data. I'm going to make all this stuff unsigned. Okay, unsigned char. This is the function that we're doing right here, just like that. Now return JGreet. That's what's happening here. Okay. Let's see. So JGreet. So this is not a char anymore. Now this is a UChar pointer. J greeting Japanese. Japanese greeting. Okay. That's how that is. J greeting. Punch it out. Now, I already said there's a null here, so I can't do this. I can't print like this. What this needs to be is for I don't need that. Let's just say while J greeting. Okay. Let's see. Print F %C. Okay, so that's like a char. That's what this is. J greeting plus. Okay. Or actually, let's see. While J greeting data. So this data, right, is pointing someplace. We're gonna move this pointer forward like this. Eventually, it's gonna hit that null that I appended and stop, printing out that string. That's what's happening here. So we're gonna say if while. Now this is getting confusing. I could just not put these parentheses or these braces I'm putting, but it's clear. So let me just do that. And so this is a little tricky. So we're taking the first character. It's going to be valid, and we're going to print it, and then we're going to add 1 to that pointer, and then keep doing that and keep printing it. And after we're done, we're going to print %n. Okay. All right. So where's my GCC in my history here? No GCC in this history. Okay, GCC dash wall dash O JG Japanese greeting dash C. Okay, let's see here. Okay. Let's see. Japanese greeting at line 15. Let's see, where's line 15? J greeting data equal mallet. J greeting. Let's see. Size. Let's see. Here we are. Expected. Okay, so add that. Let's say clear again. Right. Okay. 43, 43. Let's see. What's the problem here? I don't know. Return 0 if else return 1. Let's see here. I see. That non-static function thing gave me the clue. I was just missing that braces up there. So let's just save that. Okay. Return compatible pointer type. Okay, let's see here. Right. So you char pointer. That's one thing I had to fix. Yep. Okay. Let's see what target passage is. Turn captain. Where's that? Target. Oh, I see. Yeah. Let's see if we can fix this. Okay. Number 6. Okay, unsigned char arguments of type char. Doing all this casting. I'm only doing this because I'm trying to get binary data to move across. That's what this is all about. So let's try running this program now. JG. Uh-oh. Let's see what happened there. So it prints all that stuff out to the screen. That tells me. Let me hit reset to fix any kind of screen writing problem, because I could have set control caps to the screens. Hold on. Close all of these things, reset. Make sure we're okay. Screen. Okay, VI, Japanese screen does see. So that didn't work. I think that was a problem. Let's see. Wonder why. Okay. Oh, right. So, well, actually, I don't know. Why is that? Let's see. I am not entirely sure why that did not work. Okay, should have. It's null here. Not entirely sure. Well, let's see. Since I gave it that, no, that doesn't make any sense. Why doesn't this work? So let's just do this then. Size, wall size. Let's see here. Data plus. And let's just do that. And oh, fine. Okay, let's make this a for loop. I was trying to avoid this. I know there's a more clever way to do that, moving a pointer forward, but I can't figure out right now. So let's just do this in interest of time. For q equals 0, q less than j greeting, size q plus plus. Okay. Printf %c. decrypt data Q. Okay. And yeah, there you have it. Okay, let me go over here. JCC-wall-o G Japanese-C K JG. Alright. So it looks like, so I printed it, right? Okay. Now let's put that null, let's put a null in here. Right in the middle. Pika. And now this is one more byte bigger. This is 8 now. So let's do that. See what happens. Okay. So let's see. Pika. We lost a character. Let's see. Cat template. Copy my name size. And copy. I wonder what happened. Let's see. What happened? Where's that null? Pika. Pika, and then 0C. I'm not sure why it's 0C. Somehow. Alright, let's see here. Let me do a quick test. Right. Okay. How about this then? This will be interesting. Let's see what happens. I guess I'm gonna get numbers now. Of course. Okay, that makes sense. So what happened to that, where did that C go? How come I didn't get that Pikachu? C, unsigned char, Pikachu, 8 characters, 8 bytes. Comes back, print size. Okay, prints the whole thing. So what happened? Where did that go? Let me see here. Unsigned 8, let's see, templates, stir cat, breeding data, templates, stir cat, mining, okay, size, put a null at the very end, right? Size. Interesting. Not clear on what happened to that character. Let's see. What could have happened? What could have happened here? C disappeared. And the person's job of putting the C there is this person right here. Right? What happened? Let me add a -1 here, just in case. C, JG. Okay, Pika. Okay. So space disappeared between the name. Alright, that makes sense. Make sure. Okay, so it's not it. Gotcha. And copy. Copy some size. +1. What if I start off a little bit further away? Let's go either. Right. What happened to that letter C? Let me put a different letter here. I'm gonna verify something just to make sure I didn't miscalculate. Okay. Okay. So it's not that I miscalculated anything. Somehow the null's getting lost. Put a null character there. 0x05. Let's try this. Okay. C XD backslash this. Interesting. Okay, let's try. Let's try that. Pika backslash XC. Okay, I see what happened. So you can't do that. Backslash X00. Stay with that. Interesting. Don't know why this doesn't work. Let's see, 0x00. I feel like that's totally how you put a binary string in. Right, that's totally how you do it. So okay, I'm not sure. I'm not sure what it is. I'm not sure why this is not a 0 here. 2E 20. Should use a dot. 20 space Kideska. Yeah. 0, 0, 0A. 0, 0, 0A. 0, 0, 0A. That's not what I expected. That's not what I expected to be printed out. Why did the null get printed out like that? That's not what I expected. Hold on. -1. Let's see here. Okay, put that down and lose. Okay. It's not what I expect to see printed out to the screen. This 0, 0 here. Well, I'm not sure. I can't figure this out right now. Where's that last letters going? Only thing I can conclude is somehow I am not calculating this right. Somehow this is something else. I'm going to test that theory real quick by making this a space if I'm right, and that's 20 H like I think it is. Oh, that didn't work. Okay, that didn't work. So that means this is not what I think it is. That's not what I think it is then. Pikachu. This was supposed to be like a, let's see, 41. Sure, it's supposed to be letters. They're supposed to totally work. So the fact that this is not working like this is a problem. I have to look up something. I was pretty sure that's how you do it. So hold on. See binary hex value in string. Okay, hold on. Let's see. Binary string. It's not what I expected either. Let's see. C values in string. Zero OXA. This is very odd. Let's see here. I was always under the impression that this was the right way to do this. So I'm very surprised to see this not work. Okay, so let me see. D. Okay, Pikachu. So it printed the null. Okay, so you see this? The null got printed right here. So this worked. Why it's not working in the middle of the string, I'm having some trouble understanding. But see right there that the null did come out. Okay. I don't know what is preventing this from working in the middle of a string. I should be able to do this. Okay, I'm going to try this again real quick. Pikachu, right there again. See, the null. The null is getting printed. And the rest of the character is not disappearing. But for some reason when I do that, wait a minute. When I do this, put it in the middle of a character, somehow... Oh. Look at that. So wait a minute. So there it is. The null okay. So let me just say this. I don't know what I just changed, but it seems to work now. Okay, fine. Whatever. Let's see. Now we want to do this in Python. CP super example 2. JGreeting I override VI. So VI. Okay. Let me see how long this video is so far. 47 minutes. Okay. Function names. Now, we already talked about what is in char pointer, just a string of binary stuff. We're going to say here the function is Japanese. Hold on, I need split screen to see what I was doing. Okay, this function. Okay, char pointer star Japanese greeting unsigned char star my name int size. Same thing here. When you have these problems in Python and converting, you have to give these things called typemaps to SWIG, so it helps you convert a data out from C to Python, because you saw how it wasn't working by default at first. We just got professor without the oak. So you know. Let's see. So here we are. These functions that you're seeing here, the py things, screen underscore, they are apparently called the concrete layers, and I say that because that's what they seem to be called. I haven't seen anything that tells me otherwise. So py string underscore a string. If I click on this concrete layer, see that concrete objects layer? When I go here, I have a list of all the objects, apparently the py things that I can use to move around between Python and C. This code here in typemap is just C code. I can type whatever I want here. On in, which means coming from Python into C, when you see something like this, it comes in, and this $sign is where it is what gets as argument 1 into a C function. Argument 2 is $2, argument 3 is $3. $3. So this is me doing that, bringing it in. On its way out, right, this function returns that pointer, right, out. On its way out, back to Python result, which is what's headed for Python, is build value, string format, that structure, right, the structure was data, int size, and it's going to build a string long enough for that, whatever it is, even if there's nulls in it, build it, and for a string to come out to Python. That's what that's about. and we're going to compile this right now. So see, remove -f star.o star.so star.pyc star, or how about this, Japanese py. Okay, I think that's what the things I need to remove. So there you go. Okay, and we're gonna remove that Japanese wrap.c because I need to redo that again. Okay, so here we are. So now swig Python Japanese I. Syntax error. Alright. VI Japanese I. Okay, syntax error in 5. 4, 5. 5. Don't see what's wrong with this inside. Uchar pointer. Japanese greeting. Oh, I see. Okay. Japanese greetings is the name of this module. Okay, so we need to do that. Okay, there we are. Right, it gives us that gcc-c. We talked about that, making the object files instead of giving it to a linker and creating the final program. We don't want to do that. We just want these object files. Oh, but that didn't work. We talked about that. User include. You know, in the real world, I would have had a make file for this, but I'm just, I'm typing. This is the last time I'm going to need to do this anyway. So that's why there's no make file right at the moment. ld-shared and o-o_Japanese greeting.so. Okay, and you know what? Just in case, because I like to do it. I want to see what this looks like. Okay, so that was a clean compile. No, there were no warnings. Python+C+SWIG. See that? Okay. So you see how that worked? And VI_PY greeting. And there was a null in there. You see how the null made it across to Python and C, no problem. Originally it didn't work. And that's how you do that. That's how you move binary data between what's it called? Between Python and C. So there we have it. Now, with that pretext set up, I'm going to show you what I had to do for the new Tatsunoko versus Capcom proxy server, how it's built, how it works. 52 minutes. Let's see here. The code GameSpy-C. Okay. This is my code. Okay. These functions here I can't show you because I already talked about it before. I don't want to show encryption code in my videos. I want to keep GameSpy's encryption kind of a secret, sort of. So this right here, this is Luigi's code. I already talked about. There's a guy out there named Luigi. His name really is Luigi, and he wrote some C code for encryption. So, and I don't have a debugger Nintendo Wii, so there's no way I could reverse this. I don't have a way of debugging this in any way, shape, to see what kind of code is happening in Nintendo Wii. That's very daunting. I just don't have the tools for that. So someone has to work out that encryption for me in some other way. And the person who did it actually did it to a PC game, and the PC has many debugging tools like Ollie Debug and IDA Pro and things like that. So that person was able to work that out. And it turns out GameSpy just took that and used it in some Nintendo games like Tatsunoko vs. Capcom. So this function applies right here. Let's see. And I just call it. These are my wrappers to call those functions and do their decryption and stuff like that and send it over there. And all that. That's how that works. So, an interface file for that. It looks exactly how you'd expect it, like what I've been talking about. Oh, I can't use syntax checking here. So you see that? And the same thing I talked about, moving binary data. And why do I need to move binary data? I will show you right now. Wireshark. C players listing it. Okay. I have talked about this already, where Wireshark, you've seen this in the Hide&Seek video, where Wireshark does a search and there's a key here and there's this and all that, right? And it all comes out. And that's the encrypted data. Now, this encrypted data, it's all binary. I have no way of knowing what's going to happen. Like, look at this, for example. If I didn't do all that binary data stuff I was showing you, the UChar pointer, if I tried to send this to C, C would lose it, or when it tries to come back to me decrypted, it wouldn't make it back. There are nulls in the middle of the data. So I have to have a way of passing that back and forth when I need to encrypt and decrypt the player list that the game sends. So this list right here, I'm going to show you how this works. And I told you before that this was the key. I wasn't going to talk about this. It's just a random 8-bit key and how it works, and whatever. I was supposed to talk about that. So I'm going to dump this traffic out right here as raw. This is encrypted traffic. The game made a request about how many people are on there. Encrypted data. I'm going to save over the one that's already there, you see. Replace. Okay. Now back to entire conversation. Okay. So, see here. Background. VI test. So, you see this key? There's a game CD key. This module, TVC Secret, contains a lot of encryption algorithms that I ported to Python and encryption key stuff that I don't want to share, so you're never going to see the contents of this. That's how the proxy server works. By that thing, everybody imports this thing because it has all the keys and stuff like that that I've magically extracted from the game, and we won't talk about that too much. So, in encrypted data, I saved it to disk. That's the key to Nintendo Wii. Your Nintendo Wii, when you guys connect to your proxy server, I pick up whatever 8-byte thing they use. Your Nintendo Wii uses, I pick it up from here, and I use it in my encryption and decryption. So I'm going to do this. I'm going to open that file, which I just saved. You saw me export it from Wireshark. Open decrypted. I'm going to print it out. So let's run it. Okay. Let's go back to that. Let's screen, Python, test. Okay, see all that stuff printed out, IP addresses and all that stuff. So the way this works, this is why in the website I can say you are here, because I can see if your browser comes from the same IP as the IP I have here in the list, even though I don't show it to you in the browser. So I don't think everybody needs to know everybody's IP. So that's how I do that. And you see that player. I talked about this before. That if your number of players is where is that number of players? If your number of players is 0, it means you're not in the middle of a battle yet, and the number of players 1, it means you're fighting somebody. So that's how that works. And these are the numbers. And I have a different hack for how I pull the names of people out of the ranked battle server with these profile IDs. That's a different kind of hack. And those hacks also come from keys to access that server inside here, and I'm not going to show those. So now I said decrypted data. View. Okay, this thing. Okay, view this. So here I call it decrypted data, right? So if I'm going to call decrypted data, I need to be ready. That data needs to make it back here without losing its nulls, and I can tell you that edit. You see right here how I write the decrypted data to the disk, right? You see it right there. So edit decrypted data. Now you saw what the data looked like in Wireshark when it's encrypted. I can't make sense of this, right? I don't know what this is. It looks like junk. You see how much more it looks like better stuff here? Notice that if you think about what a database looks like, or maybe a CSV file exported from Excel, which is kind of a weird table thing, right? These look like column headers, and all these data here are points in the middle, and you see all these zeros in here? All these null bytes would have given me trouble if I don't figure out how to move them between Python and C. That's why it was very important to do that. None of this, right? This is all a problem. Notice each record, like for example, this is my IP address stored in that format, that decimal format, and then stored in hexadecimal format that I talked about in the creating lobby video, which I'm not going to go over that again. That was in that video. And this right here is a port number, and it just kind of keeps on going and going and going until it hits. From observation, I realized that the delimiter is 007E. So you see where my cursor is? See that? 007E. Right there, right there. So, and it just keeps going, and a different record is someone else's IP address in the port, and it just keeps on going until the next 07, see that? 007E. And that's how that works. So that's how I deal with this data. That's how I can see the IP addresses that were collected. Okay, and here is where I go through them. Let's see, match ready. Or actually, let me go down to alter server data real quick. So right here, I'm going to alter it. First, I'm going the original query that you get from the server. I keep it here in self-encrypted data. But what I'm going to send you on Nintendo Wii is one that I've modified. See, server data, but I've modified it here. So I send you a different one that I rebuild, alter server data here, and this is how I take it apart. See that? So I say split on that 007E, right? I discussed that already, right? 007E. See where my cursor is, the green cursor near the top. So I split on that to get each record, and I go through there looking using some regex, regular expression stuff. I seek here. I take the list apart here. See, if you're in the hiding thing, the hiding list is from when you clicked hide in the filter on the website, and alter data. I put the list back together. That's how it goes, and all data seems to end with these 6 bytes: 00FFFFFFF. I've noticed that by observation. Right here it is. So that's why I put it there, and I send this data to your Nintendo Wii after taking it apart, analyzing it, and putting it back together to remove all the people who are hidden. And I keep the original one because I'm still convinced other Nintendo Wiis can start a battle with you, even though you did not start a battle with them. See, we're at 1 hour, alright. So you'll see that here, I still keep the original data right here. That's the original one, not the one that was modified. So this is a superset, I guess, of the one that I sent you to the Wii. That way I go through here and make sure that I won't let the fight happen. And this is how I do it, by changing all those bytes. So I talked about the when your Wii needs to send a battle, sends the IP address to other people, I zero out that information. So I already talked about how, say for example, this is somebody's IP address, this stuff right here. Okay, this is somebody's IP address and port. Those 6 bytes, these 6 bytes right here, I change them to 0. I change them to 0. See that? Null times 6 is a way of saying 6 nulls. And I replace, and I have to escape because they in self might have a meta character. So yeah, you see how this works? And I replace it, and then I let your Wii send it out, and it won't work, and the Wii will just try somebody else because it's an error and it's a problem, and it doesn't work because it's all zeros, and So that's how that goes. Okay. So I have now shown you how I deal with the new custom server. I can take apart the list, rebuild it, make sure that you can't fight that person by changing it to null when I catch it here, and I maintain that list that way, and I can decrypt it and re-encrypt it and everything here. That's how that goes. And alright, let's see here. That is the code there. Now, what else did I want to show you guys? The new logic, taking it apart, unseen dangers. Alright. So let's get back to that. Okay. Let's see. I don't think we need any of these now. So we're gonna get rid of all this. CP super 1.I dot vi move. I'll just leave an example. Example 1. Or actually, we're not going to do it. We're just going to say edit string. That's what we're going to call it. And we're going to call this void edit string char star my name. Okay. Okay. Okay, here we are. Oh, I see what happened. I I haven't started the screen yet. So let me see. Move, edit, string, screen. All right. vi edit string dash c. Void edit string. Char star my name. My name 0, right? Memory access equal q. Okay. That's all this function is going to do. Nothing else. Okay. So swig Python edit string I gcc dash wall dash c edit string dash c. We already talked about these, so I'm not going over it again. Right? C. Oh, and you already know what this is. User include Python 2. Apparently, I have other stuff here. 2.6. KLD shared edit string O edit string underscore wrap O dash O underscore edit string dash SO. Alright, so Python. So my name equal SMT_DDR, you know me. Okay, if I try to do this in Python, okay, equal, I don't know, W. I'm going to get an error. Strings are immutable in Python. Now, if I do this, if I bring in that C program that I just wrapped up in a SWIG, we'll see if we can't get a different effect. Okay. Uh-oh. Undefined symbol. Let's see here. How's that? What happened? Let's see here. Close that window. This window. Let's see here. What happened? Edit string. Edit string. Vi edit string. Vi. Let's see. Python vi edit string. C. Void. Ah, here we are. And that's the problem. Edit string. Okay. Here, swig Python, GCC wall, LDD share. Okay, so Python, my name equal SMT at DDR, my name 0 equal A, can't do it, immutable, from edit string import edit string. Okay, edit string my name. That's how I got the table. You're gonna edit string. Okay, my name. It changed. The fact that I can change it like this, I've broken a rule of Python that says strings are immutable. I don't know what the best practices are if people should be doing this. That's what the dangers are. I don't recommend people do things like that, even though it works. It's not. I don't like it. I don't think people should do it. So, I'm just stating that. That was that. And the malloc and free stuff. Let's edit this function again. Okay. Let's say include malloc dash h. Okay. Let's see, how much time do I have here? Okay, it's a 9-minute video. Alright, we're just about done. Let's make this a char. Now we're going to return something. Let's return, let's see, q and then char star new name equal malloc sterlen my name. Okay. And if not name, okay, return null. Okay, otherwise stir cat into new name my name. Okay. And return new name. That's how we're going to do it. And let's see, include string.h, because as I've said, Mem said it's good to do this. New name. 0 sterlen. My name. Okay. That's a good way to do it. And so that's it. So vi edit string -I. Okay, these voids are now chars. And notice I don't have to do an unsigned char on pointer business because I'm not introducing nulls into the middle of this stuff this time. So now I can do this. Swig. Okay. GCC wall. Okay. And LD library. Whatever this is here. Okay. It's the LD shared thing. So now Python my name equal SMT at DDR. Edit string. Let's see. Import edit string as ES. Yes, I can do that, right? I can change it, the alias how I refer to after import. Edit string, my name, and it returns something. Now, you know the thing about this return? Here's what this whole malloc free thing. Whose job is it to free this? See this malloc? Where's the free? Who needs to take care of this? I don't understand. I haven't seen documentation online for that, and I don't quite understand. It bothers me a little bit. And I even have that problem here. Right? I don't understand what I'm supposed to do with this data that I've malloc. There's a malloc here, there's a malloc here, I returned that entire structure here. I don't actually understand who's supposed to free it. That kind of bothers me a little bit. So I don't know if I'm supposed to make a wrapper just to send objects back into C world to call free and then just return. Sometimes I wonder if I should do that. I don't know. So that's it. That bothers me, and that is what I wanted to show you guys. Okay, this video is about as long as I'd want it to get. Thank you for watching. That is it.